In this video, I'll go through the trigonometry preparation paper for methods. I'll do this as one big long video, so if you want to skip forward to questions, just have a look in the description down the bottom and I'll put little time tags for you. But first of all, remember you'll have a formula sheet, which I've just chopped a bit out of up here, and you may want to go through and put in the degrees for yourself on it when you do the test. So I'd sort of be going, okay, well, that was going to be 0 degrees, and this is going to be 90, and this is going to be 180. This is just a quick reference for myself later on. This one will be 270. This one will be 360. And then I know that the other ones are going to be 30, 45. I'm just going to use that just to speed myself up while I'm doing the test, okay? So let's jump in at question 1, and we'll get ourselves started. In question 1, we're going to be converting from degrees to radians and from radians to degrees. So remember, when we're going to do this, what we do is we take the 225 degrees, okay, and to convert it over, what we do is we multiply that by pi over 180. I just make that a fraction to make it a little easier. Top times top, bottom times bottom, so it becomes 225 pi over 180. And we'll simplify that fraction if we can. It's a non-calculator, so maybe we'll try dividing both sides by 5, so that will become 45 pi over 36. And it looks like I can put 3 into both of those as well, so I might simplify again to 13 pi over 12. Okay, going back the other way in question B, if we've got to go from radians to degrees, it's very similar. So they have 5 pi on 3, but this time we multiply it by 180 over pi. So 5 times 180 is 900 pi over 3 pi. Pi's eliminate one another, and we end up with 300 degrees. Don't forget your degrees. Question 2, we're finding exact values. So here we are, we've got ourselves at sine 90. So if we draw that on the unit circle, we've started here, and we've rotated to here through 90 degrees. And this point, if we write in the coordinates, is 0, 1. So we can actually see here that the answer is 1, okay? So this one will be 1. Now, you can also get that from this table, okay? So remember that here you go, sine 90, the answer is 1, okay? Next, we're going to have a look for cos 30. This one, a little bit different. So here, we're still in the first quadrant, and we've drawn our unit circle, but this time we've gone from here up to about, say, here, and we're looking for an exact value of this. Now, if we go up to our table, we can see that we've got cos 30 degrees, so it's root 3 on 2. Oops. And because it's in the first quadrant, we don't really need to do the cast diagram, but we'll do it just to show what we're up to here. Remember, it happens in this quadrant here, so it's a positive answer. So we've answered this one. When we start moving down into things like sine 240, if we draw our unit circle again, we know that this time it's going to land down here somewhere. Okay, so we'll have rotated right through 240 degrees, and this is where we need to start thinking. So here, this is really the same as sine 180 plus 60. Okay, so 60 becomes our reference angle. It's as though we are drawing it up here. whoops, daisy. It's as though we're drawing it up here in the first quadrant, okay? That's what we're thinking in the back of our minds. So we can say that that's going to be the same as sine 60, but I want to know whether that's going to be a positive or a negative answer. So I draw my cast diagram, and I tick the quadrant that it's going to land in. That's the tan quadrant, so that means that we're going to get a negative answer, and now we're looking for what that answer is going to be. So we're going sine 60, the answer is √3 on 2, and it's a negative answer. All right, tan 330 again. Let's draw our unit circle. We know we're going to end up over here, and we'll have rotated through 330 degrees. We can see that this is equivalent to tan 360 minus 30. So we're going to use tan 30 as our reference angle. I wonder if it will be positive or negative. We'll draw our cast diagram. Tick the quadrant that it lands in. It's the cos quadrant, so it's also going to be a negative answer. But now we'll go up and we'll have a look for tan 30 gives us √3 on 3. And the answer is negative. Okay. Now we've got some where we're dealing with radians, but it's no different. We know that if we're looking at our unit circle, we start at 0, we end up with pi on 2, pi radians here, we've got 3 on 2 here, and we've got 2 pi radians back here. Now we know if we travel 5/6 of pi, then we have landed over here, okay? And so we have rotated through 5/6 of a radian. So really this is the equivalent to tan pi minus pi over 6. So our reference angle is tan pi on 6. We draw our cast diagram. We tick the quadrant that it lands in. It's the sine quadrant, so our answer will be negative. And then we go looking for tan here, pi over 6, which we also know is 30 degrees, and we get √3 on 3. √3 on 3, and that's a negative answer. Last one. Now we're looking at sine. We'll use blue for a change. We're going to draw our unit circle. We will have rotated through 7 quarters, so we'll land over here. And this will be the equivalent of sine 2 pi minus pi on 4. So our reference angle is sine pi on 4. Draw our cast diagram. Tick the quadrant that it'll land in. That's the cos quadrant, so that's going to give us a negative answer. So the answer will be, if we go up to our table, whoops, sine pi on 4, it'll be √2 on 2. And it will be a negative answer. Question 3 wants us to find a value for x. Now it's going to be a number of degrees. You can tell that from this It's giving you a domain between 0 and 360 degrees, unlike the next question, which is going to ask for it in radians. And so what we're doing is we're trying to find a reference angle to describe root 2 on 2. And we go back to our table up here. And what we're doing up here is we're scanning across the sine column here for where we find root 2 over 2, which happens here, okay? And we've made ourselves a note here that it was at 45 degrees. So we're going to use 45 as our reference angle. So we'll come back and make ourselves a note that we're going to use reference angle is 45 degrees. Now, the other thing that we're going to notice is that this is positive, okay? So next thing we do is we draw our cast diagram. And we are looking for all of the quadrants where we would have a positive answer. And that happens in the first quadrant and in the second quadrant. And so this is what we base our angles off. That means that X will either be 45 degrees, because we will only have travelled 45 degrees into here, okay? Or X can also be 180 minus 45 degrees, because it could have also happened over here, okay? So that means that X is 45 and it's also 135 degrees. Question 4 has got a couple of parts to it. We're trying to solve X, we're trying to find out what X is, the value. This time it's going to want the answer in radians because it's asking us for anywhere within the unit circle, so between 0 and 2 pi radians. So the first thing is it's in a bit of a format that we can't really deal with at the moment, so we're just going to transpose or move this formula around a little bit. So we'll take root 3 off both sides, and so we end up with 2 cos x equals negative root 3. And then we'll divide by 2 both sides so that it's in the format cos x equals negative root 3 over 2. Now, this is a format that we can work with. So we're going to go hunting for a reference angle. So if we come back up to our formula sheet, we're crossing the cos column and we're trying to find where we get the answer root 3 on 2, which happens here at pi on 6 radians. Remember, this time we're working in radians. So we come down and we make our reference angle is pi on 6. Now we go and draw ourselves another cast diagram. And I am looking for the quadrants where I'm going to get a negative cos value. So that is going to happen in quadrants 2 and 3. And so now what we need to do is we need to find out a value for x. So x is either going to be pi, because remember this is pi over here, okay, minus pi on 6. It could also be pi plus pi on 6. So the two values for x are 5 pi on 6, and the other one is 7 pi on 6. Question 5 looks a bit nasty, but it's really quite easy, okay? But what we need to do is we need to just think about this angle here relative to this angle here, okay? And if you have a close look, you'll realize that sine 38 degrees is really the same as sine 360 minus 38 degrees, okay? So we can actually use a reference angle, just like we've been doing in the previous questions, of 38 degrees, okay? So that means that the answer to this is going to be either, okay, so sine 322 is going to be 0.616. We just have to work out whether or not it's going to be positive or negative in its answer. Okay, so very similar to questions 3 and 4. So let's draw a cast diagram. If we travel 322 degrees, we know that we're going to land somewhere over here. Okay, we'll have traveled through that much. So that means that we're going to ultimately end up here in quadrant 4, and that's where cos is positive. So we understand that this answer will be negative. And that's solved. There's a couple of ways of answering question 6, but I like to use Pythagoras. So what I'm going to do is go up and attack the start of this question. I can see that sine theta is 0.7, but that's not a very usable format for me, so I'm going to change that into 7/10. So I'm just converting the decimal into a fraction. Try to ignore this bit, okay? All this is doing is it's telling you that the original angle has to be between 0 and 90. Otherwise, you could potentially find 2 different angles, and then there's no limit to the number of answers that you get. So the answer to the first part of this is, or the second part as well, is that the angle must be between 0 and 90 degrees, okay? Now, getting back to it, what you can do is you can draw a right angle triangle. You can pop theta down in the corner down there. And then using sine theta, we know that sine in SOHCAHTOA is opposite over hypotenuse, okay? So taking this rule here, the opposite will be 7, the hypotenuse will be 10. And so now I can find this, because this will help me find what cos theta is. So using the formula a squared equals c squared minus b squared, I've got that x squared equals 10 squared minus 7 squared, which is 100 minus 49. So if x squared is 51, that means that x is the square root of 51. Now, we're not being asked to find what sine theta is. We're being asked to give an exact value for what cos theta is. And cos here is the adjacent over the hypotenuse. So the exact answer to this is root 51 over 10. Okay, we're going to plot a sine graph here. So we need a couple of pieces of information from this. This is also our amplitude, which gives us this and this. Okay, so straight away we know that the amplitude is 2, which means that we mark on our y-axis 2 and minus 2. And we might just pop a y and an x on these axes before we go too far. The next piece of information that is useful to me is this number here. It says divide by 2, and that's going to affect the period, and it's also going to affect the 4 key events that are going to happen on this sine wave. So first of all, if it was a normal period, it would travel through 2 pi. Okay. Now it tells me up here to divide by 2, so instead I'm going to times by 2. Similarly, each of my key events, of which there are 4, if you divide 2 pi evenly into 4 parts, you'll get pi on 2 for each of those events. And I have to multiply that by 2 as well. Okay. Now, that means that the period is now 4 pi long, and it means that each key event happens at pi. The other thing that I'm just having a quick look at while I'm doing this part is that if one wave occurs over 4 pi, okay, or a period of 4 pi, and I need to plot to 8, then there's going to be 2 sine waves here in this. So there'll be 8 key events altogether, okay? So that means if I have a look at my formula sheet, I know that the sine wave goes like this, okay? So what I'll do is I'll start marking in my events. Event number 1, event number 2, 3, 4, 5, 6, 7, 8. And then with a nice big arc, I'm going to come in and I'm going to draw my sine wave through these points. And now my job is to mark each of these key points. So the first one happened at pi 2. The second one happened at 2 pi. Next one happened at 3 pi minus 2. Remember, you don't have to mark these ones that fall immediately on the x-axis with their y value. So this is just 4 pi, then 5 pi, 2, 6 pi, 7 pi, minus 2, and 8 pi. I'll just tidy up that little 7 there. And that's complete. And question 8, we need to plot a cos wave this time. So we've got similar information. We've got our amplitude, which tells us this number, and this number. So we know that that's 3. We're ignoring that it's negative at the moment. All that will do is reflect our wave, or turn it upside down, but we'll deal with that in a minute. And then we've also got this piece of information here. It says 2 times. So this time we'll divide by 2, remembering that a normal period occurs over 2 pi. So we're going to divide that by 2. And then a normal key event, which I'm just going to put as a key event there, like that, is pi divided by 2, and we're going to divide that by 2 as well. Okay, now I'll tidy this up a little bit for you so that you can see how I do this next bit. So this bit's easy. 2 pi divided by 2 is pi, but if you're asked to do pi over 2 divided by 2, remember, make this one a fraction and change the question to 2 on pi multiplied by 1 over 2, and what you'll end up with is pi over 4. And so your key events will occur at pi on 4. All right, so coming back up here, we've got to start to plot this. If I have got a period occurring over pi, so I'm reading that from here, okay, and I glance back up here at what they want, they only want it plotted from 0 to pi, so this time I only need to show one wave, okay. Ordinarily, remember with a cos wave, it would look like this, whoops, and then, done a terrible job of that, hang on. Ordinarily, it would look like this, but this one is negative, okay, and that's important. It's going to be reflected. It's going to go upside down. So we'll begin here instead, and then our 4 key events will occur here, 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 and here, where it returns to its origin. So here we go, up and down. And now we need to go through and we need to label each of those points. And they'll be, so remembering here, now I'm taking from here that each key event happens at pi on 4. So we're going to have the first one here at pi on 4. We'll have the next one here at pi on 4, 3. Next one will happen here at, oh sorry, that's a 2. Pi on 2, 3. The next one here will happen at 3/4 of pi, and the last one will happen here at pi minus 3, and that should be plotted up. We'll cover plotting tan curves in a separate video. This one's getting very long, but you should study what I've covered ready for the test, and that should set you in good stead.